Next, Sadin, welcome to my channel. I am P.S. Videos. Previous session, we discussed the physical properties of metals and non-metals and some exceptions. So those materials are able to run into sheets are called malleable substances. Those materials which are able to run into wires called ductile materials. Those materials are able to produce a ringing sound called sonorous materials. Those materials having shiny surface called lustrous materials. Okay? Good conductors and poor conductors if they allow electricity or not. Let's discuss this session chemical properties of metals. Chemical properties of metals. As earlier discussion properties or physical properties of metals and non-metals. Physical properties of metals and non-metals. We cannot classify the elements into metals and non-metals. So what do we have? So let's discuss the chemical properties of metals and non-metals. So based on the chemical properties, maybe there is a chance to classify the elements, metals and non-metals. So metals and non-metals having different showing different chemical properties. Let's describe the chemical properties of metals and non-metals. So there are some important properties of metals. First one is reaction with air or reaction with oxygen. Reaction with air or reaction with oxygen. So when metal reacts with oxygen, it gives metal oxide. And one more important thing I am telling you. Here I did not explain any activity. I did not conduct any activity. So just I explain in this session what happened when the metals are reacting with oxygen, what happened when metals react with water, what happened when metals react with acids. So no activity is displayed because to display that to include all those required materials. So here I have no required materials. So just I explain what happened, what are the products are happened and what the nature of the substances are happened. So that only I will explain, but I did not explain any activity. So first when metals react with oxygen, it gives metal oxide, which are basic in nature. So they have basic nature. So sodium and potassium. Sodium react with oxygen at room temperature. Sodium and potassium react with oxygen at room temperature. They form their respective oxides. So sodium Na plus sodium reacts with oxygen, it gives sodium oxide. Let us check is it the balanced chemical equation or not. Should write the balanced chemical equation. So 4 Na's here, 2 oxygens. So similarly potassium also combined with oxygen and reacting oxygen gives potassium oxide. Gives potassium oxides are basic in nature. Basic in nature. Potassium, sodium are stored in kerosene to prevent their reaction with oxygen, moisture and carbon dioxide of air. So to protect them, potassium and sodium are stored in the kerosene. Most of the metal oxides are insoluble in water. These metal oxides are insoluble in water. Metal oxides are insoluble in water. But sodium oxide and potassium oxide dissolves in water to form their respective bases. So except sodium oxide and potassium oxide, remaining are insoluble in water. These are dissolved in water and form their respective alkalis. Alkalis is nothing but basic solutions. NaHO plus H2O gives rise to sodium hydroxide. Sodium hydroxide, which is a base. Biological two sodiums, two hydrogens, two oxygens, and two oxygens. So similarly, potassium oxides also dissolves in water and gives their respective organic substances. Are nothing but the basic substances are formed. So why these metal oxides are basic in nature? These metal oxides are change red litmus into blue litmus. So when sodium is reacting with oxygen, gives us sodium hydroxide. This sodium hydroxide dissolves in water, it gives sodium hydroxide. To know the nature of this substance, when we test with the litmus paper, then the red litmus turns into blue litmus. So as we earlier discussed in the chapter acids and bases, those substances are change the red litmus into blue litmus is bases. And as we know magnesium is not react with the oxygen at room temperature, but on heating. So magnesium reacts with the oxygen. And gives magnesium oxide. So when you take a small piece of magnesium from magnesium red one and we cut it a small piece, then we heat and calculate the spirit lamp. It burns with a dazzling light. Burnt dazzling light and forms ash. A white ash substance is formed, that is magnesium oxide. So when magnesium reacts with oxygen and burns with oxygen, so it gives magnesium oxide. So this magnesium oxide is dissolves in water. It gives magnesium hydroxide. It gives us magnesium hydroxide. So this magnesium hydroxide is a basic in nature. Right? So this magnesium hydroxide is a base. So this is obtained from a metal oxide called as a magnesium oxide. So as classic, so reaction with oxygen. So we burn magnesium ribbon. We heated the magnesium ribbon on the candle flame, the spirit lamp flame. So it burns to dazzling white flame and forms of ash. So the ash is collected in a beaker or some other container. So it will dissolve in water, and this resultant solution change the red litmus into blue litmus. So this is a solid and this is a liquid and this is an aqueous solution or the solution. So finally, what do we understand? Metals react with oxygen, they form their respective metal oxides. They form their respective metal oxides. So these metal oxides are basic in nature because they turns the red litmus into blue litmus. Red litmus into blue litmus. So here will be some examples. Aluminium metal burns in air and heating to form aluminium oxide. So here some of the metal oxides are behave as acidic nature as well basic nature. They have some acidic nature and basic nature. Those metal oxides are called amphotic. Those metal oxides are called as amphotic oxides. Amphotic substances. Examples for amphotic oxides. Amphotic oxides are aluminium oxide. Aluminium oxide is one example, and zinc oxide. Aluminium oxide and zinc oxide are amphotic oxides. Reacts with bases, reacts with acids as well, and forms salts and water. We already discussed in the chapter acids and bases, what are amphotic oxides. So those oxides having both nature, acidic nature as well as basic nature. Right? So generally metal oxides are basic in nature, but these are the amphotic oxides, behave as acids, behave as a basis. Then coming to the next reaction with water. What happened? The metals reacts with water. When metals react with water, what happened? They form their respective alkali substances. So here many chemical equations reactions are there regarding to reaction with oxygen. So here I explain only two water. The most important thing is when metals react with oxygen gives us the metal oxides. So then coming to the amphotic metals, then amphotic, so aluminium oxide react with acid, it gives AgAlP plus water. Then zinc oxide react with bases, it gives Na2ZnO, that is sodium zincate, Na2ZnO2 plus water, right? So is acid, it is base. It reacts with the acid as well as base. It also reacts with the acid and base. They form respective salts and water. So next reaction with water. What happens if the metals react with water? Metals react with water to form their respective metal oxides. So when metals react with water, gives their respective metal hydroxides, and hydrogen gas. And hydrogen gas also with it. For example, sodium. is a metal. As earlier we discussed, the highly reactive metal, it is stored in corrosion. When you take a small piece of sodium, it is stored in corrosion, and when you drop a small piece of sodium into the water, when it reacts with the water, it gives sodium hydroxide. It gives us sodium hydroxide and hydrogen gas. Sodium hydroxide is aqueous solution. It is a solid and it is a liquid. This is sodium hydroxide. Sodium hydroxide and also liberated hydrogen gas. So when we test this solution with the litmus papers, red litmus is turns into blue litmus. So it is a basic in nature. So all the metals do not react with water vigorously. Some of the metals react with water slowly. However, some of the metals react with cold water, some react with hot water, some react with steam, whereas they do not react with the water. So metal plus water, metal hydroxide plus hydrogen, metal plus steam. When metal react with steam, water vapor, it gives metal oxide plus hydrogen. Metal oxide plus hydrogen. Example, potassium. So even potassium also react with water vigorously. Magnesium do not react with cold water. Magnesium react with warm water to form magnesium hydroxide plus hydrogen. So magnesium also react with water, but it is a hot water and gives us magnesium hydroxide and hydrogen. So this is magnesium hydroxide. Sodium and potassium react with cold water extremely and produce their respective base and hydrogen gas. Magnesium do not react with cold water but react with hot water and produce magnesium hydroxide, which is a base and also forms hydrogen gas. So magnesium reacts very rapidly with steam to form magnesium oxide and hydrogen. Metals like aluminium, zinc, iron do not react with cold and hot water, but they react with steam to form a metal oxide and hydrogen. So aluminium and zinc do not react with cold and hot water, but aluminium and zinc react with steam to produce their respective metal oxides and hydrogen. Right? So sodium and potassium extremely react with cold water. Then magnesium react with steam and hot water. Then whereas aluminium, zinc react with steam. So aluminium and zinc do not react with cold and hot water. Iron react with steam to form iron oxide and hydrogen. Red hot iron. So this is about the reaction of metals with the water. Calcium also extremely react with water. oxides or metal hydroxide, and also hydrogen gas is liberate. So how to we test hydrogen gas liberate or not? When you bring a burning mastic near the mouth of test tube or the container of the beaker, then the hydrogen gas put off the burning mastic by making a pump, or burns with the puffs. Already you know that. Metals like lead, copper, silver, gold do not react with water, even the hot water or the steam water. So, lead, copper, silver, gold do not react with water, either cold water, hot water or steam. So, we will now discuss how metal displaces hydrogen from water. How metal displaces hydrogen from water. How these metals forms hydrogen when they react with water. So, due to the less reactivity. So, hydrogen has less reactivity than sodium, potassium, calcium, magnesium, aluminum. So, highly reactive element can displaces the low reactive element. Such reactions are called as displacement reactions, are we discussed. Right? So, reactivity 6. So, later we will discuss the reactivity 6. Then, only those metals displace hydrogen from water which are above the hydrogen in the reactivity 6. Then, coming to reaction of metals with acids or dilute acids. What happens when metals react with acids? So, metals reacts with acids, produce the respective metal salt and liberate hydrogen. When metals reacts with oxygen, so they form the respective metal salts and hydrogen gas. So, as we learned in chemical reactions and equations, when during the displacement reaction or when metals react with acids, right? Even in the acids, the chapter acids and bases, when discussing the properties of acids, when the acids are reacting with metals, liberate their respective metal salts and hydrogen gas. So, zinc is a metal. The zinc is reacting with dilute hydrochloric acid. It gives zinc chloride and hydrogen gas. So, in test tube, we have taken small quantity of dilute hydrochloric acid, and when we drop a small piece of zinc in that, so zinc chloride and hydrogen gases liberate. So, colorless gases are formed in the test tube. So, when you bring a burning mastic near the mouth of test tube, then the burning mastic is put off with puffs. So, metals react dilute acids gives their respective metallic salts and hydrogen gas. So, sodium metal reacts violently with dilute hydrochloric acid to form sodium chloride and hydrogen gas. Then magnesium reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and magnesium and hydrogen. Aluminium reacts slowly with dilute hydrochloric acid, and due to the presence of tough protective layer of aluminium oxide on its surface, but very thin outer. Then also zinc reacts dilute acid and gives zinc chloride. Iron reacts slowly with dilute hydrochloric acid to give iron chloride. So iron reacts with the dilute hydrochloric acid slowly. It gives iron chloride and hydrogen. Iron chloride and hydrogen. Ferric chloride. We can call as given iron 2. It is called as iron 2 chloride. or ferric chloride. So this is zinc chloride. This is a zinc chloride. These both cases we have taken dilute hydrochloric acid, the metal zinc and iron. Zinc and iron. But some of the metals do not, copper do not react with the hydrochloric acid. Dilute hydrochloric acid, no reaction takes place. All the metals which are above hydrogen in the activity series displaces hydrogen. Right. When a metal reacts with dilute nitric acid, then hydrogen gas not evolve, because nitric acid is strong oxidizing agent. So as soon as hydrogen gas is formed, the reaction between a metal and dilute nitric acid, the nitric acid oxidizes this hydrogen to water. So if the metals react with the hydrochloric acid or sulfuric acid, they are able to displace the hydrogen. But when the metals reacts with the nitric acid, HNO2, is a strong oxidizing agent or oxidizing acid. So if reaction happens, for example, when zinc reacts with nitric acid, it is called as a nitric acid. If hydrogen gas is formed, this hydrogen gas. So nitric acid is a good oxidizing agent. So immediately this gives the hydrogen and forms water. So metals, when metals react with nitric acid, they did not liberate hydrogen gas. Instead of they form water. So nitric acid oxidizes hydrogen to water. Then nitric itself reduced to any of the nitrogen oxide, whether nitrogen monoxide or nitrogen dioxide. So the type of oxide formed depends on the nature of the metal, the temperature. Very dilute nitric acid, however, reacts with magnesium and manganese metals to evolve hydrogen gas. Very dilute nitric acid reacts with magnesium and manganese. They liberate hydrogen gas. So whatever, when the metals are reacting with the dilute acids, so they liberate hydrogen gas. So here we will discuss some reactivity series of elements. So potassium, sodium, calcium, magnesium, aluminum, some reactivity series. Why these metals are able to displace the hydrogen from their respective acids? Sodium, potassium, magnesium, aluminum, zinc, iron, tin, lead. Then after we have hydrogen, copper, mercury, gold, right? Silver, gold. So potassium, sodium, calcium, magnesium, aluminum, lead. So this is the reactivity series of metals. So potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead are highly reactive than hydrogen. So these elements are displacing the hydrogen from dilute acids. But these are acids. Right? So the arrangement of metals in verified in a vertical column, the arrangement of metals in a vertical column in the order of decreasing reactivity is called reactivity series. Reactivity series. So why the hydrogen displaced from the acids? Because all the elements which are above the hydrogen displaces all the elements which are above the hydrogen are displaces. This is the decreasing order of decreasing reactivity series. The elements which are above the hydrogen able to displace the hydrogen, which are down unable to displace the hydrogen. Why some metals are more reactive and other are less reactive? So let me discuss how these reactivity series are arranged. Then reaction with salts. So reaction with oxygen, reaction with water, reaction with dilute acids, then reaction with salts. What happens if the metals react with chemical salts? So I hope understood this. Next one, reaction with the salts. What happens when metals react with the salts, chemical salts? Displacement reaction. Here we discuss about the displacement reaction. So there is one experiment already conducted in chemical reactions and equations, right? So metal plus metal salt or metal salt. So what will happen? One of the metal displaces by the another metal. One of the metal displaces by the another metal. So as we discussed, so when zinc is added into the copper sulfate solution, it forms zinc sulfate plus copper. Then iron is added into the copper sulfate solution, so it forms iron sulfate plus copper. Then zinc is added into the iron sulfate solution, it gives zinc sulfate plus iron. Whereas when copper is added into either iron sulfate or zinc sulfate, there is no reaction. Because of as from the reactivity series, zinc iron is more reactive than the copper, whereas the copper is less reactive than iron and zinc. So copper displaces by zinc in copper sulfate solution and forms zinc sulfate and copper. Then whereas iron is more reactive than copper sulfate, so copper displaced by the iron and forms iron sulfate and copper. Zinc, when you compare the reactivity of zinc and iron, zinc is more reactive than iron. So iron displaces from iron sulfate and gives zinc sulfate plus iron. So such reactions are called displacement reactions. A more reactive metal displaces the low reactive metal. So The activity strings of metal decide whether a particular displacement reaction takes place or not. Displacement reaction is in a chemical reaction, a metal or the element displaces by the other metal or the element. So generally, low reactive element will displaces by the high reactive element. So low reactive metal like copper will displaces by zinc, iron, aluminum, magnesium, calcium, sodium and potassium because of copper is less reactive than the other one. So however, then some activities are already done. So making different salt solutions like copper sulfate, zinc sulfate, iron sulfate, 3 beakers. So we drop zinc in copper sulfate, iron sulfate. Then we drop iron or copper in zinc sulfate. Then we observe the change in color of the solution. So change in color of solution takes place because of a metal is displaced by the another metal. So such reactions are called as displacement reactions. So as already we discussed about right. Then next reaction with chlorine. Reaction with chlorine. What happens if the metals reacts with chlorine? So metals react with chlorine to form their ionic chlorides. Metals reacts with chlorine form ionic chlorides. Ionic chloride. Simple. When sodium reacts with chlorine, it gives us sodium chloride. Sodium chloride. Sodium chloride. Right? So metal atom loses the electrons and become positively charged ions. As already discussed, the elements which loses the electrons and forms positively charged ions called as the metals, whereas the non-metals are gain the electrons. So in this sodium loses the electrons and chlorine gain the electrons. So it is a metal and it is a non-metal. Simply we can say that reaction with non-metals. Sodium is a metal, chlorine is a non-metal, and they form their respective ionic compounds. Ionic compound. So why this is called as ionic compound? Because of the substance is formed by the ions. Formed by the ions. So similarly, magnesium reacts with chlorine, it gives magnesium chloride. It gives us magnesium chloride. Magnesium chloride. Then potassium reacts with chlorine, gives potassium chloride. Potassium chloride. Similarly, iron, copper, zinc, aluminum, magnesium, all metal chlorides are formed by the when metals react with chlorine, they form their respective metallic chlorides. These metallic chlorides are called ionic compounds. Then reaction with hydrogen. Next one. Reaction with hydrogen. What happens when metals react with hydrogen? They form their respective metal hydrides. Metal hydrides. So most of the metals do not combine with hydrogen. Only few reactive metals like sodium, potassium, calcium and magnesium react with hydrogen. They form their respective metal hydrides. Metal hydrides. So generally they do not react. So some of the metals like sodium, potassium, calcium, magnesium reacts with hydrogen. So when sodium reacts with hydrogen, it gives sodium hydride. It gives us sodium hydride. So it is a solid and it is a gas. 2NaH. This is sodium hydride. Sodium hydride. Similarly, calcium react with hydrogen gives calcium hydrides. Calcium hydride is an ionic compound containing calcium ions and hydride ions. Magnesium also. Comparatively less reactive metals like zinc, copper and iron do not react with hydrogen and to form hydrides. So these are all the chemical properties of metals. So we discuss reaction with oxygen, reaction with water, reaction with dilute acids, reaction with salts, nothing but to know the reactivity series, and the example for displacement reaction, reaction with chlorine, reaction with hydrogen. Even metals react with bases. Some metals react with bases and also liberate hydrogen. For example, zinc reacts with base like sodium hydroxide. So it gives sodium zincate, Na2Zn. So sodium zincate and liberate hydrogen. So this reaction is reaction with base. Reaction with base. So these are the chemical properties of metals. So metal oxides, when metals react with oxygen, gives metal oxides which are basic in nature. So they turns red litmus into blue litmus. When metals react with water, liberate hydrogen gas and form the respective alkali, nothing but bases. When metals react with dilute acids, liberate the metal salts and hydrogen gas. So how to test the hydrogen gas is formed on when we bring the burning plastic near the mouth of the ship, then the burning plastic is put out with the palms. So that's all for this session.